In these problems, we're trying to solve for x, and you could certainly guess and check. Does 8 work? No. Does 0 work? No. Guessing and checking is not a great method, all right? Instead, let's try to use a system here. And the first system is, the first thing to do in this system is, if you have two radicals being added or subtracted on one side of the equation, separate them. So step one is add root 8x over to the other side, and it would look like this. So step one is to separate them. Do we want to try to solve 11 and 12 at the same time? The student said no. All right, so after adding the square root of 8x to both sides, square both sides. So our goal here is to rid the problem of square roots. And if we separate them and square both sides, we will no longer have a square root on the left. We might still have one on the right, but we'll deal with that later. We can always square both sides again later, all right? So what happens on the left side when you square the square root of x plus 7? You just get x plus 7. On the right side, this is where it gets a little tricky, because we're doing something plus something squared, all right? That is not just the first plus the second squared. There are rules in math. When you square a product, can you just square both if you're multiplying? The answer is yes. If those two things are being added, can you just do a squared plus b squared? That answer is no. Because when you square something, you multiply it by itself. And perhaps the FOIL technique pops into your head here, right? So you do first times first and get a squared. You do last times last and get b squared. So far, what we thought the answer might have been is going well, right? A squared plus b squared. But don't forget you're going to have the O and the I in FOIL, right? The outside, inside. The outside makes AB. The inside makes AB. How many ABs? 2AB. That's the correct way to FOIL when you have A plus B squared. And that's what I have on worksheet 5.4, number 11. I have something plus something squared. So let's take the first term and square it. What's negative 1 squared? 1. Let's take the second term and square it, but leave some room here. What's root 8x squared? 8x. And it's plus because we're squaring it. Now, we need the middle. The middle, according to this rule, is double first times second. So it's double A times B. So on our worksheet here, what would you get if you doubled this times this? Negative 2 square root of 8x. Okay? I doubled negative 1, got negative 2, times the square root of 8x, square root of 8x. So that's the first hurdle that we needed to clear. Squaring both sides and dealing with that right side where we still have kind of an ugly middle term, right? Kind of an ugly middle term. So, step one was move this over to the right, square both sides. Step two is figure out what all that is. Next, you see how we still have a square root here? Everybody around it is going to run away from it now. Get this, what I'm underlining, alone on the right side. Then we can square both sides again, and then the square root is now eradicated from the problem. And we're out of that square root level. You know what I mean? So take away 1 from both sides. Take away 8x from both sides. Since you are high school students, I figure you can write all that in one line. Notice how I'm lining up my -1 under my +7, because they're like terms. And I'm writing my take away 8x under my 1x, because they're like terms. Okay? On the right, they just cancel. And I'm simply left with -2 root 8x. On the left, I have 1x minus 8x. 7 minus 1. 6. This problem suddenly looks a little simpler, right? Only has 1 square root left in it. Nothing squared. I'm feeling okay about it until right now. I'm going to square both sides again. Now that everything that was added or subtracted to the square root is gone, now I can square both sides. Notice I'm not getting rid of that -2 by dividing. I'm just going to go ahead and square both sides. This same process would play out in number 12, which you can try next. All right. On the left side, we're going to practice again. A plus B squared. What do you get when you take this first term squared? Square -7 and square x. I'll write my answer down. You look up and see if you agree with it. -7x, the whole thing squared, is 49x squared. I'm going to save some space here and add 36 on the back end, because that's 6 squared. But what about the middle? It's supposed to be double first times second. Double -7, what do you get? -14 times 6. Or 6 times 7 doubled. 84, good. So it's -84x in the middle. All right? Right side. Now, remember this rule on the next page that I wrote? Are you allowed, when you're multiplying, to just square this and square that? Yes? Okay. We are multiplying here. Right here. These are being multiplied. Square this, 4, times square the square root of 8x. Don't touch the 8. You just get 8x there. And we're really close to this being a solvable problem from techniques we know from before. Okay? We squared the square root of 8x. The square root went away. Jack, I'm going to stop. Okay. So what is this? Just multiply. 32x. Okay. Now, the moment of truth. Originally in this problem, we had square roots, and everybody kept running away from them. So we could square both sides to get rid of the square root. Now we have x squared. And we learned before that when you have an x squared, everybody doesn't run away from it. Everybody comes over to be with it, right? X squared is more like a magnet, and everything sort of comes over to the left so we can set it equal to 0 and solve. So I'm going to take away that 32x from both sides. Take away 32x from both sides. So you have some big numbers. Big deal. Deal with them, right? So I have -84 minus 32 is -116x. Who else is over here? Who's left on the right if everything went away? 0. Here we go. We have a parabola, a quadratic, that we need to either factor, use the quadratic formula, or graph it, and see where it crosses the x-axis. Those are three methods you can use to get the answers here. You want to try factoring it? I do. I want to try factoring it. If I fail, I can try another method. So initially, when I see 49x, I immediately think this. Do you? And when I see 36, I think maybe it's this and this. Right? Okay, and if I need a negative in the middle, maybe, just maybe, it's 7x minus 6 and 7x minus 6. The only way this is true is if this and this add up to what? 116, but they don't, right? Yeah, 42 and 42, that only makes 84. So 7 and 7 doesn't appear to be working with negative 6 and negative 6. You could try negative 9 and negative 4. Does that work better? No. You could try 18 and 2. You keep trying, but this plus this isn't making the 116. So you know what I do? I cheat using an educationally approved tool known as the calculator, right? And here's how using this tool would work. Clear, clear. Get rid of everything. Clear out your y equals. And put in this parabola. 49x squared minus 116x plus 36. And let's find where it crosses the x-axis. Okay? It's a good method to use. We got a little bit stuck, but we're going to persevere using our Common Core mathematical practice standards. We're going to persevere through the problem and do 49x squared minus 116x. We've hit a little bit of a roadblock, so we're trying to find another way to do it. Was that a 36 at the end? Okay. If I graph this, maybe I'll see where it crosses the x-axis. Recap. Why do we want it to cross the x-axis? What's y at the x-axis? 0. We're trying to see where it equals 0. Here we go. Graph. On the viewing window right now, does the graph cross the x-axis? How many times? So it appears as though we might have two solutions. One of them looks kind of annoying because it's between 0 and 1. It's a decimal. The other one looks like it might be what? If I hit trace 2 and y is 0, is that good? That means that y equals 0, so x was 2. We found a solution. So we are going to go backwards here. We know one of the answers. We don't know the other one because it looked like a decimal. But if I know that x equals 2 is an answer, what would this say? X minus 2, right? If x equals 2 is an answer, then one of the factors must have been x minus 2. Could we then, now that we have that information, what would work here to make 49x? What would be here? To make 49x squared, there'd be a 49x there. What would be here to make 36? Minus 18. Now, if this and this happen to add up to 116, we're home free. Do they? This is 98x. This is 18x. What's 98 and 18? 116. Okay? That's a pretty... Was that cheating? Was that cheating? We used our tool to find what x was, and then we went backwards in the problem. So, what do you think here? I think the other one is, if that equaled 0, what would x have to be? If you divided both sides by 49, you'd get 18 49ths. That's the other solution to the problem. If you don't believe me, go here and hit trace 18 over 49. Enter. Does it make 0? Unfortunately, we need to make sure it's a solution in the original problem. If you plug 18/49 into the original problem, is it a good solution? It's extraneous, okay? Ends up being an extraneous solution. And there's an easy way to find out. And I'm telling you what, folks, I'll show you something here. Graph this in y1, this in y2, and see where they cross. Okay? There is the graph, by the way, just making sure that we saw here that it only hits once when x equals 2, showing that 18/49 was extraneous.